So 4.1b notes, we are going to be continuing our solving and graphing inequalities, but before we do that, let's go back and do a systems of equation by substitution. So remember, the whole idea here is we are going to take this equation that is equal to y, and we will plug it into the other equation for that variable, so we're left with one variable of x, and we can actually go through and solve it. So let's see what that looks like. So negative 3x plus 5, and then again, we're replacing the y with x plus 3. So we're going to take that x plus 3, plug it in there, rewrite the rest of the equation, so equals 3. Now, we see some parentheses, so we need to do our distributive property. So we got 5 times x and 5 times 3. So we get 5x plus 15. Combine your like terms. I have a negative 3x and a plus 5x. Negative 3x plus 5x gives you 2x. Bring down the rest of the equation. Plus 15 equals 3. Then we start moving some stuff around. So we need to move this 15, so it's a positive 15, so we'll do the opposite and subtract 15. 15 minus 15 is 0. Those are gone. 3 minus 15 gives you a negative 12. And then our last step is to divide by 2. 2 divided by 2 is 1. Negative 12 divided by 2 is negative 6. So again, that's just your x coordinate. We will need to now come to our y equation. So let me go ahead and write that down. Just separate this a little bit. So y equals x plus 3. X is negative 6. So we're going to plug that in there. So x is negative 6. And then write the rest of the equation, plus 3. And one more step here, negative 6 plus 3 is a negative 3. And then we want to make sure that we go ahead and write our answer as a point, negative 6, negative 3, and we are finished. There's your final answer. All right, so we're just going to jump right into some of these examples here. It's pretty similar to what we did yesterday in the 4.1a notes. So we're just adding in some extra steps now. Like this one, we have variables on both sides, so we're just adding in a couple extra steps that we had with the solving equations section. And again, it's the same thing, it's just the way that we end it is a little different. So, like I like to do is I like to move my variables over to the left all the time. So I'm going to move this 2b over. It's a negative 2b, so I would do the opposite and add 2b. So add 2b to both sides. Negative 2b plus 2b is 0, so they're gone. Left-hand side, I get a 3b plus a 2b gives me a 5b. Bring down my plus 12 is greater than 27. Now we move the number with no variable, so that is a 12. So I would do the opposite and subtract 12. Cancel those out. Bring down 5b is greater than 27 minus 12 is 15. So last step, divide both sides by 5. B is greater than 3. Come down to our number line. We put the number that we just solved for in the middle. One number less than it on the left, one number greater than it on the right. Open or close circle, what do we get here? If it's just greater than, what do you think? Hopefully you're saying open or thinking open. Greater than means I'm shading everything to the right. Next. Distributive property. We can see that we have parentheses on both sides, so we need to do our distributive property. 5 times negative 3 gives me a negative 15. 5 times d is a plus 5d. Is less than or equal to? Switch up the color here. 3 times 3d gives me 9d. And 3 times negative 2 gives me a negative 6. All right, so now, once we get to this point, now we're going to start moving everything around. It doesn't matter if you start with your variable or if you start with the other number. I like to start with my variable. So I'm going to move 9d over. It's a positive, so I would do the opposite and subtract. So subtract 9d from both sides. 9d minus 9d is 0. Those are gone. Left-hand side, I get negative 15. Minus 5 minus 9 is a negative 4, so minus 4d is less than or equal to a negative 6. Okay, Next, we need to get rid of the number that has no variable. Okay, so we're going to take that the 15, we're going to move the 15 over. It's a negative 15, so we're going to do the opposite and add 15 to both sides. Add 15. Negative 15 plus 15 is 0. Cross them out. They're gone. Over here, we get a negative 4d is less than or equal to. Negative 6 plus 15 gives you 9. Some of you thinking one step ahead. You're thinking, uh-oh, this isn't going to give me a whole number. I probably made a mistake. What did I do? We did not make a mistake. I wanted to make one of these. There's actually two of them that ended up being a decimal. So first of all, we need to recognize that we just divided by a negative number. So that involves flipping the sign. So this will now be a greater than or equal to. And like I say, I would suggest that you draw some kind of notation here so that you recognize, oh yeah, my sign flipped because I just divided by a negative number right here. And then, just go from there. So right-hand side, 9 divided by 4 gives me 2.25. All right, so put your integer. So I'm going to go 1, 2, 3 on the number line, and then we'll say right here is my 2.25. Okay, that's a closed circle. Greater than means I'm shading to the right. Okay, so again, we like to show you that decimals are a possible solution because I know sometimes when we see a number that's not an integer, we kind of think like we did something wrong or something, but it is possible here, so we do get a decimal. All right, the next two I have done for you, so if you want to pause the video and go through and try it and see what happens, you can do that, but you could just follow along with me here. So let's see what we get. First of all, we have to do our distributive property. So 7 times x is 7x, and 7 times negative 4 is negative 28. So that's what we get after the first step. Now we got to move a number, or a variable, one of the two, it doesn't matter. So I'm going to move this 7x, so subtract 7x, and they cancel out. But they also cancel out here. So this is like what I was saying in the last chapter. Anytime the variables are gone, that means that we're going to have an inequality or an equation that we have to determine whether it's true or false. So here we go. Is 6, left-hand side is just 6, is less than negative 28. Is that true or false? What do you think? Is that true or false? Ask yourself. So this is false, okay, because 6 is a positive number and negative 28 is a negative number. So 6, a positive number, cannot be less than a negative number. So this is false, which means no solution. Now, for the inequalities, when you see a no solution, some people are like, okay, well now what do I do with my number line? Because I just solved this and I ended up getting a no solution. So what do I do? And if it's no solution, what that means is that it's not any number. Like there is no number on the number line that will work. So basically what we do is we just leave it blank. I mean, I know some people like to just throw some numbers down here like that, but honestly, it doesn't matter because if it's no solution, we're not graphing anything on here. Okay? If you go through and you solve this and you end up getting IMS, so that's it. We're done with this number, example C. I'm going to do a little sidebar here. If we go through and we solve this problem and we end up getting IMS for an answer, okay, if that is one of our, because you'll see that where we have IMS, you end up with something like 6 is less than 28 or something like that, which is true. So if you get a true inequality, it's IMS. Well, then what do? Well, then we put negative 1, 0, 1, and if it's IMS, or actually, you know what, this is a terrible way of saying that because these all have infinitely many solutions. We're going to say all real numbers. And what we do is we just shade the entire number line. Okay, so just keep that in mind if you see that show up. If you get a true inequality, it's all real numbers. That means it's true, and you do shade the entire number line. All right, example D. Again, we're starting off with the distributive property. Negative 6 times x is negative 6x. Negative 6 times negative 4 is a positive 24. Over here, we have 7 times 2x is 14x. 7 times negative 3 is negative 21. So that's what we have to start off with. Now I'm going to move my numbers that have a variable. I'm going to move the 14 over, so I subtract 14x. 14 minus 14 is 0, they're gone. Left-hand side, I get a negative 6x minus 14x, which gives me a negative 20x. Okay, negative 20x, bring down the plus 24, is greater than or equal to negative 21. Now I'm going to move the number, Now I'm going to move the number with no variable. So that's a positive 24. I'm going to subtract that over. So subtract 24 from both sides. This is gone, that's 0. Left-hand side is negative 20x is greater than or equal to negative 21 minus 24 is a negative 45. Divide by the number in front of the x, so we'll divide by negative 20. And there's two things that we should recognize. The first thing is that we just divided by a negative, so this will have to change and flip your sign to make it face the other way. But also this over here is not a integer. It's not an integer, okay? We end up getting a decimal. We actually got the same decimal we got before, so should probably change that up so there's different decimals in there. But whatever, it's the same concept, same idea. So 2.25 is going to fall somewhere in that area again. So 2.25. This is now a less than because we switched it around. So fill in circle there and shade to the left. All right. One more example here. I'll go through this one with you. I'm going to bring down the 2x is less than 2x. Multiply that 2 through there, so 2 times x is 2. 2 times 1 is plus 2, and then bring down your plus 3. Combine your like terms. That's our next step here. Combining like terms is what we want to do after we do the distributive property. So I'm going to say 2x is less than 2x plus 5. Now we move the number that has the variable, so subtract 2x from both sides. 2x minus 2x is 0. Same thing happened over here. 2x minus 2x is 0, so I end up with 0 is less than 5. So what does that mean? What does it mean if 0 is less than 5? True. That means it's a true inequality, which means we have, remember, not IMS, because all inequalities have infinitely many solutions. This means that it's all real numbers. Okay, that's your answer. How do we represent that? Well, we come down to our graph, put 3 numbers on the number line, and honestly, it really doesn't matter which 3 numbers you choose. I just kind of like to center it at 0. And we shade the entire thing. So the entire number line will be shaded. All right, so there is your final answer for example E. Okay, so again, it's very similar to what we did in the solving equations. All we're doing is just representing our answer a little differently with the number line. Yeah, try out the homework problems, worksheet problems, whatever, and let us know if you have any questions.